Hello everyone. Remember this example that I was showing you in the last lecture? So X is a normal distribution with mu 100 and standard deviation of 50. We converted or transformed the normal distribution into a standardized normal distribution, and we got our Z value equals to 2. So X was 200, we've converted our X to a Z which was equals to 2. We converted your X, which was 200, to a standardized normal distribution where Z is equals to 2. We converted your X distribution outcome where X was 200, we converted it to a standardized normal distribution or Z distribution where you got a 2, right? That means if your standard normal distribution diagram looks like this, where the mean is in the center, which is equals to 0, 2 is a positive outcome, hence it lies on the upper tail. Again, please remember, on the upper tail or on the right hand side, all the positive outcomes are listed. On the lower tail or the left hand side, all the negative outcomes are listed. Since you have 0 in the middle, so this is like a positive axis and this is like a negative axis. 2 is a positive number, hence say 2 lies somewhere over here. This outcome lies on the upper tail, right? Now, this is basically what we are finding, that our outcome is less than 2. That means we will find the area, the entire area till our outcome 2. Okay, the area under the curve less than 2, less than or equals to 2. We do not have to write the equal sign because it's a continuous distribution. Okay, so this is the area that we are essentially trying to find out. Now we know, and I've said this many times, our table 1 from the appendix lists all the positive outcomes. I cannot emphasize enough on this. You have to remember, we only have the outcome of the upper tail or the positive outcomes listed in our table. Now, if you all open your book and quickly go to page number 739, okay, in the appendix of the tables, table number 1 is your cumulative distribution function, okay, or FZ. That means it records the cumulative probabilities till the outcome which is specified. In this case, in our case, Z is equals to 2. Okay, our outcome is equals to 2. Now, how do you read the table? On the first row, you see there are some numbers, and on the first column also there are some numbers. These numbers in the middle, these are all your probabilities. Notice that the probabilities start with 0.5, okay, and the last number on your table, this last number is 0.9997, which is almost equals to 1. So on our diagram, the standard normal distribution diagram, right in the middle, you have 0 or mean, right? And I told you that the upper tail's probability, total probability, or the upper tail's area is 0.5. The lower tail's area is also 0.5. This table, the standard normal distribution table, only records the cumulative probability distribution for the upper tail. The upper tail has 0.5 of all the probabilities, right? A total of 0.5. Hence, you can see the probabilities, they start with a 0.5 and they end at 1. The total probability is equals to 1, and this is almost close to 1. So from 0.5 to 1, you have over here, okay, which are all the probabilities relating to the upper tail. From 0 to 0.5, this table starts from 5. What happened to all the probabilities before it? What happened to 0? From 0 to 0.5, what happened to all those probabilities? They refer to the lower tail. Understood? From 0.5 to close to 1, all the probabilities are over here. This represents the probabilities of the upper tail. And this table does not show you the probabilities of the remaining 0.5, which is basically 0 till 0.5. That actually refers to the lower tail. This table only lists the cumulative distribution of the upper tail. Okay, that means all the probabilities starting from 0.5 to 1. Now, the number that we have to look at, how do you find that? We have to search for a Z of 2, right? Our number is 2. So let's look for our outcome 2. You will always take a look at the first column at first and then go to the first row if necessary. We will at first find 2 in the first column. Here you go, right? You have 2 over here. Now, 2.0, do we have any number after that? It's 2.0000, right? We don't have a 2.01 or a 2.02, etc. So hence 2.0, the digit after that is also 0. That means on the first column, we find for our outcome till the first decimal place. If we have any more numbers after the first decimal place, we look for them in the first column. Since 2 can be called 2.00, 2.0 is here and the other 0 is over here, you find the corresponding number or the intersecting number between them. Here you have 2 and on the 0 column, you have 0.9772. That means we can say that the probability that Z is less than 2 is equals to 0.9772. Clear? The probability of this entire shaded area is 0.9772. Clear, everyone? So the first step is to convert your X to Z. Okay, you use the formula Z is equals to X minus mu divided by sigma. Then once you found your Z, you will find the cumulative distribution, okay, for that outcome. You find your outcome in the diagram. Look for the probability, for the cumulative probability of that outcome in your table number 1, and you will find your probability listed over there. Hope you're clear.